and welcome to our session, Taking Enterprise Asset Management to the Next Level. My name is Ed O'Brien. I'm a Director of Research here at ARC Advisory Group. Looking forward to sharing some of our research and a brief overview, but then more importantly, allowing our speakers and panelists to share their observations and recommendations as we move forward in the advancing field of enterprise asset management. With that, let's take a look. Much has changed in the EAM, not only over the last decade or two, but particularly over the last few years. The digital transformation revolution has been really helping a lot, moving from a CMMS type system, more single site work management that's based on run to failure and some preventive maintenance, and moving to predictive maintenance and moving to prescriptive maintenance to get a sense for what occurred, what's occurring, and what's likely to occur in the future. And moving from an automated to a truly intelligent enterprise asset management system, and the ability to interoperate with other systems, adjacent systems, including ERP and MES systems, and also to have reliability-centered maintenance and root cause analysis and other opportunities, not only as bolt-ons, but as included within the systems themselves. And in many ways, EAM, the latest generation of EAM solutions, are very much akin to what's occurring within asset performance management as well, or APM. It's sometimes helpful to think of the evolution of EAM capabilities from the perspective of a maturity model. Going from run to failure, corrective maintenance, and a opportunity to have some preventive maintenance capabilities, to true preventive maintenance programs and expectations for it, not only based on usage and hours and duty cycles, to predictive maintenance and predictive analytics to help identify what ought to be done, and then prescriptive maintenance, what should be done, what shouldn't be done, and what other capabilities should we look at as far as capturing when is the ideal time to not over-maintain or under-maintain an asset. And all of these are part of the movement toward the right sizing of a maintenance organization, and to staff and schedule work accordingly to keep uptime at a maximum. There are other capabilities being offered now within enterprise EAM systems that go beyond simple work management and planning and scheduling. And they include very deep and robust mobility management capabilities, expanded data management, integration, interoperability with other systems, and virtual reality and augmented reality, the latter of which can help on looking at jog plans and work order instructions and training for people who may be in the field, and help them from their mobile device. So a lot of exciting capabilities that weren't available a few years ago. Also, being able to have cloud deployment allows remote monitoring and management in a much more deeper and robust manner than has been the case in the past. With that, thank you for your time, and let's listen to our speakers share their observations within EAM and what they're doing and what they plan to do in the future.
Good afternoon. My name is Jason Walker, and Ed, thank you very much for your introduction into this session. We sincerely do appreciate that. Hopefully, all of you can see the screen. But like I said, my name is Jason Walker. I'm the Chief Operating Officer, United Road. And for those of you that are not familiar with United Road, United Road is as you can see here, a family of companies. It consists of United Road Services, United Road Logistics, and Team Drive Away. And we are the industry leader in finished vehicle logistics. Not only do we move passenger vehicles, but also heavy haul transportation as well. In doing so, we move over 4 million vehicles in a given year. We have 90 locations across across North America, both the U.S. and Canada. And I'm really excited to walk that, take you down the journey that we have been on with regard to predictive maintenance. As you can imagine, the number one challenge that we have as a company in being a transportation provider is with it's with manpower and drivers and technician shortages. The driver and technician shortage across the United States is well documented, and is perhaps the #1 risk that all transportation providers face. Backfilling open driver positions, just the cost of filling that position alone is on average $4,000, and that does not include the lost opportunity cost that you have in not having a truck filled and running down the road. I like to say that one of the things, the next hardest thing to hiring a driver and retaining a driver is hiring and retaining good qualified maintenance technicians. And so that shortage is worsening by the day, unfortunately, much like the driver shortage. And we have to find innovative ways really to address those things, because simply doing it via brute force and just trying to hire more people and put more people behind the wheel and into our maintenance shops, while that is a part of our solution, is not the end all be all solution that it once was. And so we talk about the driver and technician shortage being one pain point, and how those things are intertwined. But another pain point that not only that we as a transportation provider, but all transportation providers face is with unplanned downtime. One of the next to compensation, perhaps the next important thing to a driver is being in a truck that is reliable, and they can, because that truck really determines what their livelihood is and what their compensation is. And so it's of utmost importance that each and every truck that we have is running to its maximum capability. And so that's where, and I say, unplanned downtime is that second pain point for us. We want to make sure that our trucks are running, because not only is that impacting our customers, but that impacts our bottom line. And as we look at the unplanned downtime, we also look at the fact that that comes with a cost. More often than not, the cost of getting maintenance done externally outside of one of our internal shops, of which we have 17 strategically placed across the country, it's an additional 20 to 30% markup just on getting maintenance done externally. So whatever we can get done within our shops and planned within our shops, the better we not only make the driver experience, but also the better it helps our bottom line from a profitability standpoint. So when it comes to how do we achieve satisfaction for our customers, satisfaction for our drivers, and increase our driver pay, really it comes to making sure that our trucks are running and maximizing the uptime, and that our trucks are reliable. That the reliability of the truck really gives the driver some assurance, if you will, of what he can expect or she can expect to earn, and give them some assurance that they won't be on the side of the road. So that's those are the things that we're trying to solve for across the country. United Road is made up of 2,000 company drivers and independent contractors, and we're split roughly down the middle between independent contractors and company drivers. And so the processes that we find that be beneficial and best practices for our fleet, we're also utilizing those same tools for our independent contractors to help them continue to build their business. So one of the things that we have found to be successful for us, and that I want to talk to you all about today, is a solution that we have found in Uptake Radar. So Uptake, really, what I say has helped us in sifting through the noise that we get from the analytics and the data from our trucks. What they've done is taken industry analytics application that, as it says here, enables proactive maintenance optimization and proactive solutions. As you can see on the screen, the various things that the system is monitoring on a daily basis for. But I will say this, that the insights that are provided to us via the Uptake system have dramatically changed how we look at maintenance within our business and how we manage maintenance. And so I'm going to take a little bit and explain exactly how this works. And certainly I am not the uptake expert. We do have some of those that are part of our panel that can help answer some of those questions, but I'll explain it to you from, I'll say my layman's terms. And really, we have always gotten data from our trucks. And these trucks, as they run down the road, are well-tuned vehicles, fine-tuned vehicles that have a lot of computers and a lot of information coming out of them. But what we found with our technicians, as they would get feedback from the trucks on fault codes or failures and different things like that, it became overwhelming for them. And they would simply get so many so many readings that they would have to look into that they really didn't know which ones to really look at, and some unfortunately turned off some of those notifications, which is not the ideal situation, but you certainly understand when you are being inundated with messaging from the truck. And so what the uptake radar system has done for us is it has taken all that data that's coming in from the trucks and taking those various points and saying, if A is happening and B is happening at the same time, then that must mean C is about to occur. And once it devises what is about to occur or what failure that the truck is going to realize, it then sends us an insight. And so now our technicians are not receiving a variety of alerts throughout the day. They're getting one insight that is saying, here's the potential problem with the truck that may cause a failure. And so what we then do with that information is we then take that, we get on the phone with the driver, get on the phone with the fleet managers, and understand what's the driver seeing, and does that information coincide with with the insight that we receive from the uptake radar system. Based upon that conversation and based upon the insight received from the uptake radar, we will then make the decision to either route the truck into a repair shop immediately because the failure is imminent and it's a severe failure, or we will say perhaps the failure is one that isn't going to fail today, but we can schedule the driver into a maintenance facility sometime tomorrow or over the next week. Or in some cases, we may find that the failure isn't something that we need to address right now, and it can be addressed at the next PM cycle. And so based off of that, we're able to better manage the fleet and better manage where our breakdowns are occurring and when our breakdowns occur. So one of the just an example of a NOx sensor failure, in one particular example, the uptake insights began notifying us 21 days ahead of time. The insight was such that we felt we could wait to get that serviced, and so we brought it in at the next service interval and was able to make the repair. And one of the things I'll say is that of the insights that we have when we make a repair, we bring the trucks in to do the repair, what we're finding is that in many of those cases, the warning lights inside the truck may not have illuminated. And so what that signals to us is that the drivers were unaware or would have been unaware that there was a problem. And so if the driver's unaware of the problem, the driver's not going to bring it into the shop to get corrected. And so the uptake radar system is alerting us before the driver even recognizes that. And I'll give you an example of how some of our drivers have become. One of our drivers became a believer. We had a driver that we received this a failure code or insight saying that a failure was going to happen. We contacted the driver and walked the driver through what we were seeing and instructed the driver to bring the truck in to get serviced. The driver, not seeing a warning light inside the truck, said, "Nope, I'm fine. I know my truck better than any computer that you have, and I'm not bringing it in." And that driver, continued down the road. Within 24 hours, that driver was on the phone with our emergency breakdown team, reporting that he had broken down on the side of the road. Had the driver reacted when we had alerted him to react, then that driver would not have been inconvenienced. Our customer's freight would not have been delayed, and we would not have incurred the costly expense to repair that truck on the side of the road when we could have repaired it in one of our shops in a more planned and in timely fashion. What we have seen in the initial pilot that we ran, those two terminals, we've seen a 26% reduction in our on-road breakdown events in its base year over year. And so some of the other final outcomes of the pilot that we ran, like I said, we ran a pilot based off of roughly 10% of our fleet. We did that for 2 months, and you can see some of the savings that we saw over that 2-month period. Certainly, when we look at 1,000 to 2,000 trucks within the fleet, a savings of $3,400 per vehicle is significant. And probably as important as this financial savings to us is the lack of inconvenience to the driver. I'll take you back to our number one pain point, and that is the hiring and retaining of good drivers. And so one of the things, if we can make their lives any easier, then we increase our chances of retaining those drivers. And we want to continue to do that because that helps us continue to drive our business forward. That continues to increase the earning potential of our drivers. And it also helps us on the maintenance side of things to better plan, how we maintain our trucks. And so I will also say one of the other ancillary benefits we've seen from this. Now, United Road, as I said, we're the largest transportation provider in the finished vehicle logistics space. And so in that, if you've ever seen a car hauler truck, you'll know that it is a truck unlike any other. And it's not as simple for us when a truck breaks down for us just to go and get a rental. Believe it or not, Penske and Ryder and those great companies, they don't necessarily have a stock pile of spare car hauler trucks that we can just call upon when a truck breaks down. So it's really, really vital for us to make sure that we maintain our fleet the best way possible. And and one of those things is going to, like I said, from a predictive standpoint with regard to maintenance and predicting any potential breakdowns, because at 2 o'clock in the morning, it's very difficult to find an alternative to move our customers' vehicles simply because there are no spare car hauler trucks in a rental market. And so that's another added benefit we have seen in reducing our breakdown events. And like I said, a 26% decrease in on-road breakdowns for 1,000 to 2,000 trucks running across the country is significant. And so as we look forward to what the future holds for us, like I said, we had a pilot that we ran for 2 months, 2 of our larger locations, representing 10% of our fleet. We have now made the decision to begin expanding that to a wider array of our fleet. And so we now have it in many more cities, many more terminals across the country. And we're seeing more and more insights come in. And so I will say this, as you probably saw of a couple of slides ago, you saw a number of 400% return on investment. And while we certainly did see that from our initial pilot, as we continue to look at what that return on investment is as we have expanded it, I'll give you an updated number. We have come off of that 400% ever so slightly. And so our return on investment right now on our extended usage of the uptake radar system is at 390%. So we're still right around that 400% return on investment. And I don't know about you, but we at United Road, you don't have every day you don't have an opportunity to bring about a 400% return on a specific investment. And so we have found that this is certainly something that has been very worthwhile for us, and certainly look forward to any questions that you may have toward once all the presentations are done. So thank you very much.
My name is Mike Minard. I'm the Senior Innovation Specialist at New Brunswick Power Corporation, and I'm really thrilled to be here today to talk to you about our use of Spot so far and where we plan to take the platform in the future. So before I dive into our specific use cases around Spot, I do want to talk a little bit about NB Power just to set some context on our operations and where we are in the world. So we are the primary supplier of electricity to the Canadian province of New Brunswick. We're located in Eastern Canada, right on the East Coast. We share a border with the state of Maine, the province of Quebec, and the province of Nova Scotia. We're also connected to the province of Prince Edward Island by the Confederation Bridge. We have around 2,500 employees at NB Power, and we have around 350,000 direct and indirect customers in our system. So our NB Power is a fully vertically integrated utility, and that means that we have all parts of the electricity value chain within our operation. So starting with the generating plants, we have multiple different types of generating facilities around the province. Everything from nuclear to oil to coal to natural gas and diesel, as well as our hydro system, hydroelectric dams that we have along the St. John River here in the province of New Brunswick. We also have power purchase agreements for wind farms, as an example, in the province. And we have the transmission system, so we have all of the high voltage wires that move the power around in the province between the generating facilities and the substations in your homes, as well as a number of really valuable interconnections that we have up from Quebec, as well as from the New England states over to Prince Edward Island and down into Nova Scotia, which means we're able to wheel power through the province. Between those jurisdictions, facilitate sales of, for example, hydropower out of Quebec down into New England or into Nova Scotia. So that's a really a great advantage that we have. Also on the transmission side, we have the independent system operator is a part of NB Power as well, which is quite unique and contributes to that vertical integration. And then, of course, we do have the distribution of electricity in the province as well. So from the substation in your city or town out to the homes and businesses that would be served off of the distribution system or the distribution wires and poles that you would see on the side of the road. And the customer relationship, including even service businesses like water heaters. We own about 80% of the water heaters in the province. Street lights that we rent to municipalities, as well as being the delivery agent for energy efficiency programs in the province for all fuels. So all of that to say, we do have kind of visibility and line of sight to all aspects of that electricity value chain. And for opportunities like Spot, it really gives us a chance to look holistically across the electricity business to be able to look for opportunities to leverage the technology and ultimately gain some benefits. And in terms of that approach, so I work, as I mentioned, in the emerging technology area at NB Power. And of course, like all of you on the call, obviously are here because you're interested in Spot and applying it to your operations as well. Of course, we recognize that need to be exploring and piloting these new and emerging technologies for the benefit of our business and as well as our ratepayers. NB Power is owned by the province of New Brunswick, by the provincial government. And obviously our mandate is to keep rates low and stable and good quality of supply for our customers, for New Brunswickers. So anything that we can do to reduce cost, improve safety of our workforce and of the public is obviously a huge benefit, and new and emerging technologies are a great way to be able to do that. And our group also works with, besides folks like Boston Dynamics and our industrial partners and technology companies, we also work closely with universities and community colleges. And a really good example of that is we actually have one of our Spot robots. We have two. One of them is actually right now at a New Brunswick university, which is, looking at ways that we can leverage the data coming off of sensors or other outputs from Spot to be able to glean insights more easily and really kind of add some value to that as really a new piece of master data that we can have access to in the business. So to get into the use cases and where we've seen some value, so I'm going to talk today about our Bayside generating station. And if you were part of the Boston Dynamics user conference that happened about a month ago, you would have heard a lot about this use case, and it was referenced in one of the keynote addresses. So what you're seeing on the screen here is our Bayside generating station. So you'll see there's kind of three stacks down there, kind of in this on the southern portion of the plant. That portion of the plant is actually largely decommissioned. We do have a generator in there that we're actually leveraging some of the heat and the steam that we're able to salvage from the combustion turbine unit, which is just up here in the gas turbine building. And actually increase the efficiency of the overall system. A lot of folks are doing that where it's possible to do so. But other than that, largely the kind of core of the operation now is in this section here that's surrounded in blue. So inside of the gas turbine building, this is a shot of one side of the equipment. And if you take a look up there where I have the yellow square, yellow rectangle, you'll see a pipe, and that pipe is a high pressure steam pipe. It's about a 4-inch pipe. Of course, there's insulation around it as well. And that pipe runs at about 1,000 degrees Fahrenheit. So the steam coming through is about 1,000 degrees Fahrenheit and at around 2,500 pounds per square inch. So obviously a really significant piece of the operation, has a lot of pressure and a lot of heat. And back in early summer, we had a notification from the company who manufactured the unit that there was a potential that a weld that was between two different alloys of metal that could fail, and it could fail kind of unexpectedly. Not, it wouldn't just kind of start small and get bigger. It did have the opportunity or the potential, however remote, that it would actually just split apart and start to expel that steam into the plant environment. And of course, with that significant of pressure and temperature, it's a pretty significant risk to people to be in anywhere near that pipe if something like that were to happen, as well as having the opportunity or the chance that it would damage the plant. But of course, the safety of the people is the absolute priority here. So as a result of that and discovering that may happen, we actually had a do not operate order on the plant if people were going to be anywhere near there. There was an exclusion zone for this side of the plant. And anyone who runs a industrial facility like this, you would be aware that we need to continuously do operator rounds to make sure that there's no oil leak or that there's no issue with the equipment that would necessitate a shutdown or change of operational state. So one of the folks at the plant actually had heard that we had the Spot robots in on a pilot basis or on a testing basis, and gave me a call there one day and said, we think we have a place for use of the robot at the Bayside generating station. So as I learned more, of course, it was a really kind of clear use case for Spot that we could send Spot into the space to be able to facilitate those operator rounds and keep people safe. So in terms of what that looks like, this is from a camera that we had mounted onto Spot. So I went down to the station, walked Spot through and trained an auto walk mission. So that means I literally just piloted the robot through the plant on a path one time, and Spot was able to remember what that path was and exactly how to navigate around the site. That meant that the operator, so with the gentleman who you see here, was actually able to stand outside of the facility, just outside of an overhead door, to be able to keep the remote control in range. And he was actually amongst a dozen operators or so, and they were trained very quickly on how to use the robot. A matter of a bit of safety training of how to handle the robot, how the emergency stop works, that sort of thing. So that was a really solid use case for Spot. One thing I'll note here is that the footage where you see the operator or you see Spot walking around, that was actually captured before the plant came back online. Where the footage from the camera here was actually a real life one of the runs that they ran through the plant to do a real life inspection. So here's Spot going up one of the graded staircases in the plant. The robot ran very well. We ran for over 40 days with multiple kind of inspections per day, a couple of times per shift. and upgraded stairs down these graded walkways, through these catwalks, or I guess we'd call them a dog walk now, and ultimately was able to help us keep the plant running safely over the course of that 40 plus days. And we had a pretty significant operational savings as well of not having to, for example, sell back natural gas at a loss, or buy replacement power from a more expensive source, and we were able to actually produce the power ourselves. So with that one use case, we actually paid for the Spot pilot program multiple times over, and really demonstrated the value of Spot inside of the operation. So that was kind of the Bayside use case, and so now to talk a little bit about what's next. We have 2 Spot robots, as I mentioned. So one of them lives in the lab that I talked about with our university or higher education partner here in the province, to have further development, look at the sensors that are on board and how we can better leverage that data in a more kind of straightforward fashion. And the second one will be actually used in pilots around the corporation. So really what we kind of see happening is that we would show up at a facility, provide a demo for the local staff. One thing we've noticed with this is that as soon as people see the robot, they come up with multiple different ways that they're able to use it to create value. A really good example there is that we have a number of remote facilities. So we have over 200 substations and terminals out in the network, well over a dozen power plants, and some of those power plants are actually remotely operated in the off hours. So if you get an alarm, for example, back to a central monitoring location, if we had a robot on site, we could actually send it to do that initial bit of reconnaissance to see, is it a false alarm, or is there something that we actually have to send people to? Obviously, there's cost associated with sending people in to take a look at something in the middle of the night, and we are in Eastern Canada. We do get some pretty significant snowstorms, so the more we can avoid sending people out into the field to look for something, particularly if it's a false alarm, obviously there's a pretty significant safety, time savings and cost savings benefit there, and we can potentially even bring things back online sooner. So that's kind of the immediate next steps, and then of course that would all of those learnings from those pilots would help us build business cases to potentially acquire more robots to put them into the permanent use case full time and work on things on an ongoing basis. So I do want to thank you for taking the time to join the webinar today and hear a little bit about our story of how we've used Spot here in New Brunswick. Of course, happy to take questions at the end of the webinar. We'll give the caveat that I'm not a power plant engineer, so if you have specific questions about the nature of the steam pipe or the details about the operation of the power plant, I'm not the guy to answer that question, but certainly you're welcome to put those questions in and we can get them over to the experts here at MB Power that can help you with that. But more than happy to take a crack at answering any questions you may have about Spot. So looking forward to the rest of the webinar, and I'll turn it back over to the next part of the agenda. Thanks very much and have a great rest of your day.
Hi, my name is Kevin Price. I'm with N4. Today, we're going to be doing a presentation on one of our unique customers that's out there at PepsiCo Frito-Lay. The discussions we've had with them over the years have been interesting, from the very basics to the advanced, moving to reactive, to preventive, to predictive, and then some. Presenter that we will typically have today is Bob Zimmer. However, he got called to another meeting that he couldn't change for us. So today we've been fortunate because we have Marty Osborne with us today. Marty is with Advoco, and he is the partner of ours that did the implementation out there. So really excited to have him today to be able to share their story. Marty?
Hey, Kevin, how are you doing, man?
Good to see you. Thank you for pitching in.
Yeah, no worries. I love to tell the story of our customers, and I think some of their journeys as they've evolved, I think, as we've talked about, from CMMS to EAM to really, moving to the Industry 4.0 platform. And so glad to be here.
Thank you for joining us. You have a presentation you can share?
I do. Let me set this up and share this with everybody. So again, thanks to everyone for being here and Kevin for having me. Frito-Lay is interesting in that in their fleet, there's so many things that they've been doing. And so what we've always seen is they call it data-driven decision making and what they're doing together. And so if you look at kind of Frito-Lay Pepsi as an organization, it's close to 70,000 assets, from tractors to straight trucks to vans to material handling, all kinds of different asset classes. And, when you think about kind of today's world and the pandemic, one of the areas that has really grown is right, the Frito and Pepsi world, because as they say, almost every day is their Super Bowl. People are at home, they're eating snacks. And so have seen, huge demands, which has put a lot more pressure, right, to get chips, get drinks delivered, which then puts more pressure on their assets. And so having a real critical supply chain tied to assets is so important. So you can see what kind of assets are going. And really what they found and what we've done and seen in these projects is everything kind of starts at the asset level, right, with that asset. And where things have changed is, while it is good about work orders and costs, and we'll talk about that, the key was, how do you surround that asset now with more data, right? So from engineering specifications to the geolocation to maintenance history, fuel transactions, telematics, and driver trip records, right? And when you start to think about every time that asset is touched in any different way, not just from a maintenance, but in its use, what kind of data can you gather that can help drive that asset? And so the key was, and as we got into working with Pepsi and Frito-Lay, right, the key was integrity. And again, one of the biggest things as you get started is it's easy to start thinking about data. The hard part is, does it have integrity? Are you, what's your quality and confidence in that data? Because it can help you drive it. And again, if you take miles, for example, which is very big in the fleet, in the early days, people were writing it down on a work order. But is that the right number? Did they put it down? Did they miss a digit, right? And numbers could actually be all over the place. And so tying miles in with your geospatial data and telematics now kind of took care of that. It also said, how are we classifying trucks so that we could make better decisions, so that not all assets are created equal? Maybe it's by region, maybe it's by manufacturer. What are the areas that you want to do? And so I think with accurate data, when you first start out on this journey, you're going to run into some blind spots. You're going to see where statistics don't exactly make sense. And I think as you look at the Frito Pepsi journey, there was a lot of missteps early because the data was bad. But once you get started, it starts to show itself. You start to see those anomalies and you get them out, and then you're able to really start to do the proper analysis to see how your assets are performing. Now, when you start to talk about data-driven, I think the biggest thing, and it's always funny, we always ask the question, what does winning look like, right? So people always say, hey, what kind of numbers, what kind of KPIs? Well, a lot of it is back to, what does winning look like? So what are your organizational strategies, priorities, and really culture? And once you know that, then we start to go down the line, like, let's look at the equipment profile, like how are we going to start gathering the asset data? How many assets, do you need at your current life cycle to make better decisions? What are our buy versus replace type criteria? Like, where do those numbers go? And really, at some point in time, ROI always plays, right? What is the cost savings or risk when we do this? Because at first, a lot of times we start down these journeys, and Kevin, you know this, we've talked about this a lot, is people look at maintenance as an expense, and when you do, right, you don't want to spend the money. But if you look at maintenance as an ROI, right, as a tool that can help save costs, can increase production or increase deliveries, then it makes a difference. So again, I think as you get into this world, this is one of the things that Frito and Pepsi were really good at, is sort of breaking this down so that they understood that as they got numbers, why they were getting it, what was it going to do for them, and then really, as I said, what does winning look like? Now, this is like my favorite graph in the whole world. Like, you just got these worms going up. But really what this is showing you is through data analytics, each one of those lines is a vehicle, right? And so over time and over miles, they are capturing, repair costs, miles costs, gas, everything that goes into that vehicle. And what you see here is green is what are sort of acceptable, like, okay, those numbers fit within our range. Orange says, hey, we're starting to get out of balance. We're starting to achieve costs. And red are really the bad actors. And so when you start to look at these numbers, you start to see that grouping. Now, as I mentioned earlier, one of the challenges they had was if you just looked at it from an asset perspective, all you saw was these one or two lines. But based on how we classify them, how capital goes into this, the different, whether it's a natural gas, it's a diesel or a gas, or what types of assets, all of a sudden, as you look to the right, you start to kind of smooth that data out, right? And so to the bottom right, you started looking at the manufacturer and the full life cycle. What they start to see is which manufacturer has the lowest cost over time, right? Because one vehicle may operate better in the short haul, one asset may do better, but ultimately, if I look at it, I can see it. This can now help us make better decisions on buy versus sell, what we're buying, how we're buying, maybe go back to the manufacturer and say, hey, you gave us a warranty to this and your costs are now there. And so to me, this one just jumps out at me as why we do this. Why do we gather all this data? Why is it important that our maintenance people close out their work orders, put their spare parts and everything goes in? Is once I have this data, now I can make really true life decisions on the assets and what their full life cycle is. So again, I think improving reliability through increased efficiencies, not just increased expense, is a balancing act. And again, what we battle each and every day is that negative impact, right? We have a reactive focus. We treat our asset management more as a constraint than a catalyst. And so we kind of we look at repairs and PMs and just equipment, and we're kind of in this world. But when we truly move to kind of reliability focus, and I think we start to look at our data, now we start really having positive impacts on the business. We start looking at how planning and scheduling plays in it, how PMs are done, and not just because I have to do them to tick my box, but how does that PM actually affect reliability and what's going on there? So again, I think as you start to move in this world, you really have to say, I got to get out of reactive, right? And I've got to move to, reliability. But you also have to remember reliability at any cost is also not sustainable. And sometimes I think people like to put this blitz on, and we can do a lot of stuff and spend a lot of money. But again, we have to do it with the right processes. We have to do it with the right tools. Now, I want to show you this one example, and I think this also is a great example of where data and technology, and I think around the industry 4.0, maintenance 4.0 world's going, is we got to start listening to our assets, right? Our assets are talking to us each and every day. And based upon how we listen, we can make better decisions. And so what you're seeing here on the screen is actually battery data that goes into their vehicles and batteries on their lifts, right? So a truck goes out, what's the worst thing that really happens? And probably the number one failure they have is a battery goes bad, right? Truck doesn't start. They're sitting at a client, they're full of product, Now I got to go tow it. I got to figure out what's going on. I got to move the product. I'm behind schedule. And really, you're taking a $250 battery and you're probably causing a $2,000 event, right? And so the question was, how do you solve that problem, right? How do we get to it? And what they found is through capturing data by every time that vehicle is cranked, and you see that blue line, eventually that cranking amp starts to drop. And what they found was when I reach a certain point, we know that that battery is going to fail. And when I can predict it for $200, that battery may have a little bit of life left, but is it worth 2 extra days or 1 extra week? And it's funny is we've even seen data where drivers had to get their route done or thought they did, knew that they were in trouble, and then they took the vehicle anyways, and then it didn't start. So this is just one example where we're starting to see data and our assets talking to ourselves, which can save millions of dollars, not just in the cost. Again, it's a cost of a battery, right? A battery that may have a couple weeks left. Pull it out before it fails, right? And so let the equipment talk to us, gather that data, and when they found that, they really were able to get notifications, take corrective actions, and really start eliminating what was the number one cause of downtime and the number one cause of excess cost just by listening to their assets. So I think this, again, is a great example of looking at data and how maintenance is starting to change the way it does business. And so those are just kind of briefly some things that we saw that I think as you look at your maintenance journey, right, in such a big vehicle is listen to your assets, gather the data, start to capture those costs. And when you do, they allow you to take the corrective actions that ultimately I think are worth millions and millions of dollars in savings. And now we turn really maintenance from that expense line to how do we really make it an investment in the productivity of what we're doing. And we kind of have a saying here is how can anybody reach their goals or meet any of their company objectives without safe, reliable equipment? And again, from Frito's standpoint, how can they deliver the Cheetos if their trucks aren't running? So really kind of just quick synopsis, wanted to share this story with you. I think it's a great story that applies everywhere else. And so, Kevin, if we have some questions or if you'd like to share, I'll turn it back to you.
Well, thank you very much for your time. It's clear that automation just takes us to the next level. Being able to understand that data is always difficult. Hearing from Bob and the discussions he's always had is, I don't really know what to do with this data, just kind of put it in the data lake and we'll figure it out. And that's really kind of true, right? There's a lot of sources of data that came in. It's been an opportunity for them. It's also been quite a challenge for them to be able to understand how to do business better, how to make better decisions, how to push the asset envelope, how to be able to push longevity in a big way. Looking at one question, and we'll kind of cover it because we were running out of time, is in this post-COVID world and within automation, do you think that in post-COVID the automation has helped, or has that automation, that data really been a hindrance? The reason why I ask is because in other industries, the automation has been good because it's reduced the amount of touch points that humans have back and forth and that kind of thing. What are your thoughts there?
Well, I think it's absolutely helped. I mean, as I mentioned earlier, you think in post-COVID, how many chips are people were sitting at home, right? During the day, people are eating more chips, drinking more beverages, right? And so as demand goes up within the infrastructure, they had to be able to deliver it. And, again, if batteries are failing, trucks are failing, then they're not able to service it. So, I think without this technology, without knowing what's going on with the assets, I'm not quite sure they could have serviced their customers as well as they have.
That's a great point. Listen, Marty, thank you for the time, for filling in for Bob. Excellent work as always, and wonderful to hear the story of PepsiCo. Thank you for your time.
Yeah, thanks for having me.
Great job, gentlemen. And Marty, a great way of communicating what was going on with Frito-Lay and Bob Zimmer, your mutual customer. And great job in showing with the power of not only EAM, but also analytics. Thank you both. And we'll circle back shortly. Right now, and I'm just going to give an overview. We're going to be looking at from various panelists and circle back to Jason, but also to Braden from Uptake to kind of give an overview, and then we're going to work through some questions. And then over the near the end of the panel discussion, feel free to ask questions via the Q&A box, and we'll get as to many of those as we can as well. So Jason, great job. Very, very insightful in the differences in not only rolling stock, but also in the auto and vehicle hauling industry. Braden, would you mind introducing yourself? And then I have a question or two for you.
Yeah, thanks, Ed. So my name is Braden Pastalaniec. I'm Vice President of Transportation and Logistics at Uptake, and have been working with Jason at United Road over the past year or so. And also, notably the PepsiCo and Frito-Lay team that we just showed a great example of what analytics can do. So happy to be here.
Great. So my first question is, and this is Jason as well, but if from Braden's perspective, whoever feels most likely to want to answer, it seems a lot of telematics are a major boon for what's occurring, and particularly in rolling stock, but in general. Just a thought on that, and maybe I can add in another question that I would have is, how does that affect the life cycle of these assets as well, and the thoughts of where we're heading in these directions.
Yeah, absolutely. I'll start off, Jason, and then would love to hear your input as well. So, telematics is a great source of data for all of these assets on the road. And it's one of many data points that continues to give us insight into how that vehicle is acting, how it's feeling, operating, going down the road. And there's many, many different types of telematics providers that can be installed on a particular asset. So what Uptake is positioned to do is be the layer of intelligence on top of all that data that's being collected. Again, go back to a great example that Kevin and the Advoco team just went through is these batteries or these engines. Jason talked about the NOx sensor insight. These components are giving us second-by-second feedback as to how they're performing and how they're operating. And we can leverage a data transmission and the machine learning and AI to pick up on the very early indicators of potential failure and allow the operators to take action on that. So integration with all of those different telematics providers is certainly key. And then when it comes to how that impacts the vehicle life cycle, certainly if you're able to fix the early warning signs of a failure, and I'll go to an example that had a long tail impact with the Frito team. This was their compressed natural gas engines. And being able to quickly identify an early valve recession within a compressed natural gas engine allowed them to make an early repair, as opposed to letting that issue continue on and cause a downstream catastrophic failure months down the line. And so all of that allows you to really elongate and extend your asset life cycle. Jason, anything to add there?
Yeah, and so I'll add this. When we talk about telematics, one of the things to keep in mind is, and I tell our team this all the time, there's a difference between data, information, and intelligence. And certainly telematics does a fantastic job of providing data and information, but the question becomes, what do we do with it? And so that's where I found our team was really struggling in saying, I got all this data, all this information, and now what? And in our environment, United Road is, I'm sure, much like many other corporations across the country and across the world, in which you're always trying to do more with less. And so, how do I get mounds and mounds of telematics data? Now, what do I do with it? And so that's where we've been really excited about the progress we've made along with Uptake, and really taking all of that telematics data and really, I'll call it the evolution of telematics, because it's turning it into intelligence. Now that's something that I can do because it's actionable steps that people can do, and it makes it simple for them. And therein lies the benefits, and therein lies the success that we enjoy.
Great, thank you, gentlemen. Next, we're going to circle back to Mike Minard, but also to Matt Knights from Boston Dynamics. Matt, why don't you give us an overview of what you do in the company? And I guess I'll layer in my question is the idea of wide-legged robots. Clearly there's a great use case, and you can see the power. Would love to get the thoughts on that, because it seems to be, Spot seems to be quite maneuverable.
Yeah, sure thing. Thank you very much, Ed. So my name is Matthew Knights. I'm the director of sales for the team at Boston Dynamics. Boston Dynamics has been in the business of legged robotics and R&D and around legged robotics for about 30 years. But we just recently, a couple of years ago, launched Spot as a commercial product. So to get to your question, Ed, think about the facilities that were built, 50 years ago. They have stairs, graded walkways, gravel, curbs, tight spaces, and obstacles that need to be avoided. Those are the environments that humans operate in every day. They're really difficult environments for traditional robotic solutions, though. So having legs gives Spot the ability to navigate unstructured terrain like this. But most importantly, Spot is able to carry up to 30 pounds of different payloads. So it provides a solution in these environments to bring key sensors like visual cameras, thermal cameras, gas sensors, acoustic sensors, to do the inspections that need to be done without having to send a person into that environment, either due to safety concerns, like in a nuclear containment area, or logistical challenges like an offshore oil rig or a remote substation. So that's where we think the big advantage around Spot comes from. And then the next step for us is really taking advantage of Spot's capability to walk around these industrial facilities and to bring autonomy into these environments that were not built with autonomy in mind. Collecting more data more regularly and more efficiently by having Spot go do multiple inspection rounds per day and upload that data. So that's sort of what we're focused on. And happy to answer any other questions that come up.
Great, gentlemen, thank you. Going back to Marty and to Kevin, how are things, particularly in rolling stock, moving from preventive to predictive maintenance? And also, maybe I'll add on another question from that perspective. With so much data, how do you make sense of it to be not inundated with too much data?
That's a great question. I think Braden talked to this, Jason talked to it as well. And it just seems like the answer is always, just throw it in the data lake, we'll figure it out later. And it just gets so much. There's an entire deluge of data that comes in, especially from telematics systems. And when do you overlay them? Why do you overlay them? Is it data that you also need to bring in from third party, such as weather condition? That tends to be a big one. Operator characteristics even tends to be a big one. So what we're seeing is on a regular basis in rolling stock, and this isn't just within over-the-road vehicles, right? These are some rail as well. We have a lot of customers that are managing rolling stock in different ways and capacities, but is trying to do more with that data. I can't articulate or repeat or emphasize more what Jason said, is we have all this data, but we've got to know what to do with it. And that's what everyone's running into, that exact problem. What to do with it, when, why, to what extent, how can it benefit, how can we not? So what we typically find is the concept of just throw it in the lake, we'll figure it out later, is common. And you look for an anomaly, you look for a problem, you look for where you can be able to have an impact. If you're trying to do an initiative about operator driver behavior patterns, for example, and this is the data that you see, maybe that could help it out. And then once you do, then you start to identify that trend, that path, what you're trying to build in. You put your algorithm to it so that you can be able to understand it. You make it learning so it can learn from the adjustments that you make. And then you start to go on to the next topic. Now, fortunately, these overlay to each other, which folks from Uptake, as an example, know very well. They do a very great job of this, and so do many others in the space. But being able to learn from it, being able to automate from it, is really what people want to get to. They want to know, just as Jason said, the asset's going to fail in a bad way, and we want to know ahead of time when it's going to, and also have that prescription of what to do beforehand. So it's a commonplace, Ed, that we're hearing more and more, and the approach that people are taking. depends a lot on the acuity of the people that they have on hand to be able to understand that data and know what to do with it.
Thank you, Kevin. We also have one other panelist, Greg D. Greg, would you introduce yourself and give a bit of your background? Then I have a question for you as well.
Sure, thank you, Ed. I'm Greg D. I'm the president of HubHead. We focus on asset and maintenance master data across the asset lifecycle and helping people do the basic prep work they need to do to get value out of some of these new technologies that we've heard about today.
So, Greg, what have you seen in your vast experience as well of this evolution, and some may say revolution, from CMMS to EAM and other technologies that are adjacent technologies? What are you seeing, and what do you perhaps looking at as more promising over the next year or two within the industry?
So, I mean, you know, looking back at 2020, one of the big disappointments of 2020, not just COVID, is the number of people who haven't laid the foundation to take advantage of some of these technologies, right? We still see people who, you know, don't even get the most out of basic CMMS functionality, who maybe don't have, you know, all their assets in the system, who don't have a hierarchy set up to do, you know, some of the APM analysis that ideally you'd be able to do. You know, we also, you know, a great thing last year that we noticed is a lot of people are upgrading to real, you know, latest versions of some of the EAM systems that have amazing functionality and amazing potential. The challenge is making sure that in connection with those upgrades, they configure the systems to support APM and new technologies, predictive analytics, making sure the data foundation is set up correctly in those systems to support that they have, you know, process-oriented hierarchies set up to support APM, that they have, you know, failure codes set up. Those are significant challenges, but they're best handled in connection with upgrades. So, you know, we strongly been encouraging people to take advantage of that functionality and lay the groundwork for some of these new technologies. Other things that we see, you know, and I noticed today, there, you know, most of the people who presented had a focus on making sure the information was useful to people in the field. Who aren't as sophisticated as, you know, as the engineering and design folks who've traditionally developed and worked with some of these technologies. You need actionable alerts and information that work for operators and maintenance people in the field. And that's something we're starting to see more of. Good training for, you know, your bread and butter maintenance and reliability teams who are out there trying to get the ROI out of some of these technologies. So that was a great trend that we saw in 2020.
Great, Greg, thank you. For Jason, we have a question that's come in from the attendees about connected vehicle, and whether or not you've looked yet, or if others are heading down that path of extending capabilities within the connected vehicle concept.
Yeah, I'll say this: we have not. Yeah, we have not gone down that path quite yet at United Road. One of the challenges for us, certainly with that regard, is just the general makeup of our equipment. You know, like I said, if you've seen a car hauler, you know it's not the prettiest truck running down the road for sure. And where the posts are and how the cars are sitting on there, that compromises the ability at the current moment for some of that connected vehicle type of technology. That said, it's certainly not, we're not, you know, opposed to that should the technology, you know, allow for that. I do know that there are, you know, others that are trying that in the, I'll say in the, you know, in the general freight business and connecting trailers and things of that nature, but we haven't ventured down that road quite yet.
Okay, thank you. For Mike, and or Matt. The thought of, we've had several questions. I'm trying to consolidate the questions. Kind of the thought for within not only a plant environment, but also with Spot. Are there other variants of Spot? Or is there also thoughts of drones, and that may be outside of your area, Matt, in many ways, of whether that's a different type of use case, but just the thought of kind of what's next in both for within the plant environment, but also within robotics.
Yeah, so I can let Mike talk about some of the other technology that they're using. You know, Boston Dynamics, we are really focused on legged robotics. You know, and we don't see, you know, our robot as a competitor to a drone as much as we see as a different type of solution. So there are times when it makes a lot of sense to use a drone, and there are times that it makes a lot of sense to use legged robotic. But, you know, Spot is going to be the platform for us for the foreseeable future, and we'll continue to add, you know, additional software capabilities. Like we just released a manipulation arm. So once you find a problem, now you can do something about it and you can fix it. We just released a software solution that gives you the ability to control the robot from anywhere in the world, as long as you're on the network. So Spot will be the main platform from a robotics standpoint, but we'll continue to augment it with additional capabilities. You know, a lot of folks know us from dancing robot videos and things like that. So the days of Atlas becoming commercialized, you know, that probably isn't going to happen anytime soon. There are no particular plans. So yeah, Spot will continue to work for us really well, I think, into the future.
On the, I can just comment on the drone piece. So we've had a number of pilots and kind of real life production projects using drones for a whole range of different applications in the operations. And what we found is there's really kind of two sweet spots. There's a sweet spot for drones. There's a sweet spot for Spot. So in the Spot case, it's really designed, as Matt said, to go where humans into human design or environments that have been designed for human access, and to inspect things that generally you would have a person in there doing it. And our Bayside use case was perfect for that, because we were looking for something that would offset the need to send a person into that dangerous, potentially dangerous environment. So that was really kind of the sweet spot that we see with the legged robot. Where we start to get into drones is, you know, can we offset the need to set up scaffolding? So we have that situation often, or to go out and rent a scissor lift, or to, you know, get into these climbing operations, you know, to inspect a telecom tower. I mean, we operate our own microwave network in the province, and that involves, you know, sending someone up into up to the top of a microwave tower. So inspections we could be doing there with drones. So really, I think there's sweet spots for both technologies, and you know, absolutely applications for both, and we're moving in that direction on both sides.
Interesting, thank you. I have one side question. On those videos on this is for Matt, that are wonderful videos. What's the name of the robot that looks like an ostrich, and what's its main use case going to be?
Yeah, so that's Handle. And Handle is, you know, a robot that's sort of focused in the logistics space. So moving boxes, depalletizing and moving boxes is the real focus there.
So it also has quite a bit of rhythm. I know when they do "You Love Me" video, it look really good, really good.
Interestingly enough, you know, we've been known for our videos, and people have seen Atlas, which is the humanoid, do parkour and do flips and things like that. The robotics challenge around dancing was actually a lot more difficult for the team. So that's one thing people don't realize. And the other thing is, you know, that the initial 2 minutes of that video where you saw all the robots dancing together, that was a single take. So, you know, often people think either this is CGI or it took them 1,000 times to get this to work right. You know, it took a lot of development to get there, but once it got there, it's very repeatable.
Interesting. So Kevin and Marty, a question as far as, I know we talked a bit about preventive and predictive, but what's next as far as moving toward the kind of the elusive prescriptive maintenance? What can users do? What can plants do and what can fleets do to kind of get ready for knowing what to do and what not to do? Any thoughts on that?
Oh, it's tons. It really goes back for us more times than not on structure of data, building out the process, building out the procedures for data collection. We've actually used Spot too, Matt, by the way. We have Percepto is works that we've done with at Infor, at least, is some work with that organization. So excited about that. But being able to capture that data as an example, or any type of condition data as an example, Ed, it needs to go in the right space. It goes in the right process. So capturing it externally like that, capturing it through a drone, capturing it through a telematics system, all that's good, but it's got to go in the right place and it's got to be built into the right structure. So we get a lot of questions about, do we need to go back to the basics? Do we need to go look at how assets are hierarchically set, or structurally set? Do we need to look at ISO standards to do that? Maybe 14224 is a great one that we can look at doing a lot of that, but there's also process standards like ISO 55000 that we can take a look at. How do you manipulate those? When do you manipulate those? How do you change them? Do you put security behind them? It gets back to a lot of the basics of how assets are set up so that you can look at it as an entire fleet, whether that fleet be vehicles over the road, whether it be another type of structure, or it could just be looking at the facilities themselves. Being able to have those decisions, being able to get those opportunities to be prescriptive about a dynamic condition that you found, or any type of predictive element that you found, can only be really done well if you have all the history that goes with it. So if it fails, I know this is what I should do. I know this is how I should do it. I know this is the person I need to be involved, so that I can then prescribe to that technician, maybe that operator even, of what to do when that event occurs. So to do that, it takes a good bit of building. Now there's some great works that you can do, and there's a lot of great partners out there to look at to be able to bring some of those libraries in. I really implore those who are thinking about it to consider that, but then overlay it with the history as how it's set up and how it's built in. If you don't take advantage of that in the beginning, when you're starting to really map out where you want to go, you're never going to get there. Or if you do get there, you're going to be looking awfully confused. So the idea is to be able to build that house out right, make sure that structures are done, the data elements have a place to go to, and you can be able to roll it out correctly.
Thank you, Kevin.
And Ed, if I could just add a little bit to that. So from our perspective, integration into EAMs or CMMS systems like Infor or like TMT for United Road is critical, because as we're reading the real-time data coming off the truck, the key input into our machine learning models is what repair was actually done. So in the future here, and in the near future, we'll be able to say, for that NOx sensor insight that Jason is surfacing to his field members, 97% of the time, it's replacing the inlet or the outlet NOx sensor, and here's the diagnostic process to get there. So again, clean data is key, integration into these multiple systems, allowing that machine learning and AI to kick in and really take it to the next level.
Exactly.
Mm-hmm. So Greg, to Kevin's point about back to basics, I know you do quite a bit of work with large petrochemical companies and other heavy asset intensive companies. Your thoughts as far as not only whether regional companies, but whether or not international companies, as they're going to the next generation of systems, and they have to migrate not only their parts data, but their equipment data. Any general thoughts, not trying to make it too simple because it's not, but what should someone do who's looking to upgrade their system over the next year or two?
So, we're helping a number of companies in that situation right now, migrating to, future versions of EAM, adopting the right industry standard for their asset hierarchy is a hugely important step, as Kevin suggested. ISO 14224 is well established in the oil and gas industry, but really can be extended to most process industries. If you look at power generation, you're probably looking at KKS or RDSPP, depending on your technology portfolio. So adopting the right industry standard is a starting point, and making it work across all your facilities is the first thing I think people need to do, and get agreement and buy-in from all their different business units. One of the one of the challenges is what you do with the historical information that's been generated prior to adopting those standards, because there can be a lot of useful information in the historical transactional information that some of these systems might want to exploit. That's a factor that I think you should think of as well, plan for it. And, there are solutions, including one of our own that help with that. But then the hard work of going through facilities or drawings and making sure the assets are organized properly according to the standard across all the facilities, right? One of the things we still see is people, doing an ERP upgrade that includes the EAM upgrade and using the same consultants who know nothing about maintenance and reliability to migrate the EAM master data. They're much better off when they retain a firm for that piece that understands the challenges, right? And that's something we spend a lot of time educating management on. It's not an IT data quality issue. There's no one in IT who knows, how to maintain rolling stock, right? They're not gonna tell you how long a task takes or, properly classify assets. So having the right people, adopting the right standards, taking the right amount of time to do it, all are critical factors that will ultimately yield the results you need from these new technologies.
Okay. So I'm trying to consolidate a couple of questions here as well about, and this, I guess maybe this was kind of as a tee up for perhaps Kevin and perhaps Braden, but it's actually open to all. How do you get a sense, how do we as an industry, various industries, get a sense for intermittent problems that maybe are not as clear cut? I guess in some ways, a question maybe leaning toward not only predictive analytics, but maybe machine learning. What should we be thinking about if we want to start monitoring, but also predicting possible failures that are not clear cut and not consistent, but yet are outliers? But to the point earlier in one of the examples, you may know something 21 days ahead of time. You may know something 2 months ahead of time, but you didn't know it, but the data was there. Any thoughts? Maybe I'll start with Kevin and then Braden and anyone else as well of like, how do we kind of head down that road to really get a sense for whether structured or unstructured data, but how do we start being able to use that as we head to the future?
That's a great question. How do I search for the things that I know I don't know, but I know are out there? If anyone followed that, that's first off, I recommend is getting help from outside the organization. Sometimes it's always, not sometimes, always good to take a look at the forest instead of the trees. So when you have somebody come in from a third party view, especially, you can take a look at all the data that you have, and you can help get a sense of, well, maybe this is an anomaly in your eyes, but it's actually something that it's an opportunity for us to be able to go after. So being able to look at it from a fresh pair of eyes is always good. When we do implementations, typically we're going to have an approach called a case management, or some of the things that we do as what we call surprises that are like this. It could be a very positive type of data set that doesn't necessarily mean it's something that you go reactively change, or maybe change how you manage preventive maintenance schedules or tasks or anything like that. But it could be something that you can look at. Maybe you want to repeat this activity. You want to repeat this operation, repeat what's going on. So the anomaly that you find could actually be a very positive thing. What you don't want to find are the anomalies that are bad, but that's why you're there, is to be able to locate when things that are bad. And what are the variables that come into play to be able to produce that effect? Is it reproducible? Sometimes it's not. Sometimes it's just a fluke occurrence. Sometimes it could be something that's related to a part usage and the expectation of what it was supposed to do and what it's not. Sometimes it could be on how that part was implemented, installed, how it's operated. There could be a lot of different factors that come in. Being able to go through and find those kind of things and find out what you don't know is best served, in at least my opinion, my personal history, by getting somebody from outside to take a look. It's always good to go back to the data. Again, the rules we always hear, rule of thumb is throw it in the data lake and we'll figure it out. but you got to continually look at that data from a fresh pair of eyes. Is there something else that we're not looking at? Is there another view that we can take a look at? Where can we find opportunity? When you find that opportunity and you can be able to address it, the question is then can it be repeated? The technology really lends itself for that repetition and that cookie cuttering in many instances, but not all the time. But it's definitely a good way to be able to see where I have opportunity by taking another look. Make sense, Braden?
Yeah, absolutely. And I think, a couple of ways that we can look at this once we have those optics is, Uptake looks at it two distinct ways. One is aggregated content. Can I learn from others in the industry about these failures, about what data has led up to these failures? Is there an optimized preventive maintenance strategy that I can put in place to avoid these failures in the future? Is there pre-trained predictive models that have already been deployed and are generating insight for others, and leverage that type of content for your own benefit? And then the other side of it is what we call machine learned anomaly detection. This is the ability to look at sensor data, whether it's a singular channel or multi-channel, and without understanding necessarily the failure that's going to happen, watch those data signatures and the trends as they go along and identify when something goes outside of a normal activity. This will take the additional step of a subject matter expert or somebody who's really familiar with that particular asset to put a failure tag on it to say, when this data deviates from the normal pattern, it means this. But we can identify those unnormalcies in real time as we're reading the multi-channels of data.
Great. I'm going to try to consolidate. We probably have another 7 minutes or so. I consolidate several questions on Spot. So Matt, the question about augmented and virtual reality. I know that's a big question, but also for everyone, thoughts about maybe using particularly augmented reality in maintenance. Any relatively brief thoughts on whether it's something you're actively searching now or looking or actively watching?
Sure. Yeah, I can touch base on it based on Spot. So, Spot is built as an open platform, so it's got a Python API, so you can integrate, any type of sensor, any type of technology. Microsoft's been public with some of the mixed reality work that they've been doing with Spot. Other things that we've seen integrated is, 3D LiDAR scanners. So going into environments and getting up-to-date point cloud data that you can then use, to determine radiation maps, to look at as-built drawings, those types of things. And we have seen integrations with, Trimble. We announced a partnership a little while back, along with a few others that have built integrations there as well. So in those cases, Spot is really the transportation mechanism to bring those types of sensors into the environment. Hopefully that answered the question for you.
Mm-hmm. Open to the group. Any other thoughts about near or intermediate term use of augmented reality, or if you're using it now? Any general comments?
I can add a little bit on that. So in the, I would say, more intermediate term, we have some really kind of neat ambitions around things like switching scenarios that would happen out in our substations and terminals. You can have 2 or 3 switches lined up next to each other with, 1 digit is the only difference on the serial number that you're looking at. So obviously there's control steps in place and things to make sure you're opening or closing the right switch. But that's a huge place for improvement, because if you open or close the wrong switch, you can put tens of thousands of customers out of power or have a potential safety issue. So that's definitely something that we're looking at as a high potential use case, as well as for other equipment and plants and things, just as that extra validation step of almost a virtual or automated peer check to happen in those types of operations.
Any other observations on, particularly on augmented reality? So I also see, and Jason, not to put you on the spot, but Marty as well, between the rolling stock and in both United Road Services and Frito-Lay. And I also know Uptake is working with PepsiCo too. Just general thoughts about the complexity. Jason, you had mentioned never really thought as much about, I know with the configuration and low height of car haulers, but also the fact that they're really more gooseneck type trailers. Any general observations as to how the OEMs, whether it's the engine or transmission manufacturers or others, are working with you to, Jason, I guess this would be primarily for you, to be able to make your life easier in the future?
Yeah, so I'll tell you this: the OEMs are certainly trying to figure that out, and they have some, I'll say, some products that that do lead to, not necessarily the insights that we're getting through the uptake radar system, but they haven't quite quieted the noise just yet. And so there's a lot of different alarms and sensors that are still going off. Now, that said, I think each of the OEMs that we work with understand that they're in a customer-driven business, and they have to be more customer-centric and understand that, and are working to make adjustments. The challenge that we have, and speaking specifically in the finished vehicle logistics, is that within the grand scheme of things of transportation, car hauling is still a niche group. And so some of the challenges that we have really are around, does an OEM change their manufacturing process at the plant for this niche group, which may only make up 10 to 15% of the vehicles that they may make in a given year? Is it worth that to them? And for many OEMs, the answer is no, just because car haulers aren't buying as many trailers as a Frito-Lay or someone else may be. That said, that's really what pushed us to have to look at, I'll say, partner with other companies like an Uptake to do something from an aftermarket standpoint, just because car hauling in and of itself doesn't command that level of attention within the grander scheme of things with some of the OEMs.
Thank you, Jason.
Mm-hmm.
Well, looks like we only have a couple of minutes left. So Eddie, I don't know if there's any closing comments from your perspective. I really appreciate everyone. I really appreciate all the great insight and all the great questions. And if we missed any, we'll come back through and see. But I think if I've missed anything, let me know. I think I got most of the themes. Tried to consolidate the themes, but this has been so much fun and so interesting, and appreciate everyone's effort. And thank you very much. And hopefully you'll enjoy your next sessions as well.
Thank you.
Yeah, thank you very much.
Thanks, everyone.
Thanks, everyone. Be safe. Thanks.